The contamination of soils by hydrocarbons constitutes a major environmental problem and is linked to the economical and industrial development of our society. When a soil is contaminated, its physical-chemical state is altered, and the flora and fauna can be seriously affected and may cause irreversible damages to the ecosystems. In the face of this worldwide problem, the BIOXISOIL Project emerges as an innovative instrument for the decontamination of hydrocarbon-affected soils. BIOXISOIL has been coordinated by the Center for Energy, Environmental and Technological Research in collaboration with the Spanish Navy, the Polytechnic University of Madrid, the Association for the Research and Industrial Development of Natural Resources. The project, developed in San Fernando, Cádiz, covers 1.5 hectares of one of the Navy's installations dedicated to the storage and supply of the Navy's fuel. The land contamination is the result of the corrosion of old tanks, pipelines buried in the ground, and oil spills. The Navy made modifications to the facilities, providing them with greater safety both in transportation and fuel storage, but the presence of spillage in the grounds was still to be resolved. The initial analysis of the land included a network of test pits and dozens of probes, essential to understand the extent of the surface and depth of the spillage. Many areas exceeded values of 5,000 milligrams per kilogram of hydrocarbons. The BIOXISOIL project addressed this scenario by proposing an innovative in situ and simultaneous application of 3 technologies that combine chemical and biological strategies. The in situ chemical oxidation, consisting of the injection into the subsoil of an oxidizing reactant with a catalyst and a chelating agent of great efficiency in the desorption of the hydrocarbons and their transformation into molecules of better biodegradability. The bioremediation, based on the degradation capacity of organic pollutants by soil microorganisms, BIOXISOIL has promoted the improvement of living conditions of these microorganisms by providing nutrients and oxygen and applying surfactants that facilitate the desorption and accessibility of the pollutants. The phytoremediation, consisting of the introduction of fast-growing plant species and biomass, which, through their biological functions, promotes the biodegradability of pollutants and can even absorb it. For almost 3 years, BIOXISOIL has simultaneously applied these techniques, monitoring its efficiency through a rigorous and systematic survey sampling, along with long-term laboratory and greenhouse tests, obtaining a greater knowledge of the interaction between the 3 techniques. BIOXISOIL has demonstrated that the simultaneous application of the 3 techniques accelerates and enhances site recovery versus individual technical application and provides an excellent example of how similar problems can be addressed in other situations. BIOXISOIL completed its activities with the environmental restoration of the site, introducing native plant species indigenous to the Bay of Cádiz Park, a natural reserve that borders on the recovered area. Lastly, BIOXISOIL has installed an educational program on the site itself, explaining the project in detail through real spaces, information panels and models.